Welcome back to my favorite people, and thank you very much for watching this lecture video. And in this lecture, I'm gonna go through again the electrophilic substitution, but this time the starting compound is gonna have two or more substituent. In that case, how do you want to add the next substituent and where you want to add it? So the first example, we have methyl versus nitro group. Methyl is an electron donating group, while nitro is electron withdrawing group. Methyl is going to favor the ortho position. The ortho position for methyl are those two, and also the para position. That's a para position for the methyl. The para is already taken, so that's not going to be an option. While the nitro will be favoring the meta position. The meta position relative to the nitro, it will be here. So that's going to be the meta position. So I'm going to put them here. So as you see, both of them are favoring the same spot. So if we add like an electrophile, like let's say a BR2, the addition is going to happen here. It's going to happen on this carbon. So we will have BR in ortho position. And how about this one? That's not going to happen. Why? Because methyl is not favoring it, and also nitro is not favoring that. Methyl is favoring the ortho positions, and the para, which is already taken, while nitro is favoring the meta positions. And as you see, the bromide is inside the meta position. Okay, next one, both substituents are electron donating. One is alkyl, the second one is oxygen with two lone pair is a hydroxy group. In that case, you have to go after the stronger electron donating group, and hydroxide is favoring these two. Let's go with this color. Hydroxide is favoring the ortho position and the meta. Meta is already taken by the methyl, so it's not an option. While the methyl group is favoring these two and that para position, which is taken by the hydroxide. So these two positions cannot happen. Okay, we can't have any addition in those two positions because they are taken by OH and the methyl. Now, yellow is favored by hydroxide, and these two are favored by methyl. Where do you want to add? Okay, where do you want to add the like a NO2 or nitro group? Nitro group, you should add it here. This is going to be the major product. And can I have, for example, this product? Let's see. There we go. OH and CH3. Can we have the NO2 here? It can happen, but that's going to be really small portion of the product. So this is going to be the main product technically, or the major one, and this is going to be the minor one. But again, I'm telling you that this one is going to be the dominant product, and the second one, you're going to get a small portion of it. Okay. Next one, I have alkyl substituent, and I want to add nitro to it. Where should I add the nitro? And the alkyl is going to favor the ortho and the para position. So ortho and para position. We can add the nitro here and say NO2, or we can add the nitro there, and that's going to be NO2. Okay, let me make the bond a bit shorter. Okay, now, if you put it in a para position, you will have less steric effect. If it's in ortho position, you will have some steric effect, and that's going to be an issue. So which one is going to be the major product? This is going to be the major product, and this one will be the minor. The ortho, it will be minor. Now, next one, I have two alkyl substituent, and they are in para position. And so in that case, I'm going to say the isopropyl will be favoring these two spots. Let me highlight them. So those two spots, they will be favored by the isopropyl, and the methyl is favoring the ortho position and that one. Okay. Okay, now I'm gonna say these two are taken, so we cannot use them. Question is, where should I put the nitro? And one idea is like, let's say the isopropyl, it has a stronger, donating effect or induction effect than the methyl, so we should put it in. No, we should put it in ortho position relative to isopropyl. And if that's the case, then we get NO2 here. And somebody might say, you are dealing with the steric effect, so you should put it in ortho position relative to the methyl, okay? Relative to the methyl. Which one is going to be the major product? The major product, again, is going to be this one. Why this one? Because the steric effect between isopropyl and nitro is higher than nitro and methyl. So in both cases, we do have a steric effect, but methyl is smaller than isopropyl, so I'm going to say the one on the right side, it will be the major. Okay. Next example, we have two substituents that they are in a meta position. And in that case, I'm going to say the isopropyl is favoring these two positions, while the methyl is favoring this position and ortho, and also here. So, okay, in this case, okay, both group they are technically directing to the same spots. Okay, same spot. They are ortho. Okay, we have ortho position here relative to both of them. Okay, this one ortho to the isopropyl, but para to the methyl. And this one is going to be ortho to the methyl groups. Now, question is, where do you want to put the nitro? Okay, one idea, let's put it here. Okay, let's put it here. So I'm going to put the NO2 here. That's one. Next one, we can put the nitro here. And the last one, we're going to put it there between them. Okay, and again, I see more steric effect between the nitro and isopropyl here. This is this one, it will be methyl and nitro, less steric effect. So that's going to be the major product. This one, it will be the minor. And last one, we have nitro group that is between the two substituents. We're going to have too much steric effect. So this product will not be produced. We're not going to get that product. So do not put the new substituent between two already existing alkyl substituents, because you're going to build too much steric effect. Okay. Now, sometime you want to put like the electrophile or the substituent in a specific position. Okay. And but when it comes to benzene ring, if you have any activator on it, it's going to activate ortho, okay, ortho and para at the same time. So this is alkyl group, and alkyl group, it will favor both ortho and the para position at the same time. So now, how do you wanna force the electrophile to show up only on the ortho position? I want it to be here. So I want the bromide to be there. Let's say that's a substituent that we want to add. So whatever we are doing, we need to block this one. So we have to block the para position. And what's the best method to block the para position is to use sulfuric acid. If you use high concentration of sulfuric acid, it will put SO3H substituent in a like in a para position to the alkyl group, and it will take the para, replace hydrogen by this substituent. Okay, so now I have this group here in a para position. The only position that is available, it will be ortho relative to the electron donating group. Alkyl group is favoring the ortho position, and SO3 is electron withdrawing group. Electron withdrawing group, it will favor the meta position. Okay, so I'm gonna say the SO3, it will favor that spot. That's fantastic. Both of them are technically leading or pushing to the same spot. In that case, we will have bromide in this position, in ortho position. Now, time to get rid of the SO3H. SO3H, it can be easily removed by using diluted solution. Okay, what's the reason behind it? The reason behind it, you will get technically a reversible reaction. So whenever you put SO3 on the ring and by high concentration of sulfuric acid, you can remove it if you introduce the product to low concentration from the same acid. Okay, just simply dilute the product, the solution, and the solution, sorry, the reaction will go back. Okay, again, why? Because I have a reversible reaction. So first step, I'm going to use high concentration of acid, and this H, the H that we have here, it will be replaced by SO3H. Now the para position is blocked, and remember the alkyl group is favoring those three positions, and one of them is taken, the para is taken. So now we have BR2, and BR2 I can use in the presence of Fe, Br 3 times, or Lewis acid, and that's gonna add bromide in ortho position, while the para position is already taken by this substituent. So now we will have bromide there. Okay, this is our product, but we need to get rid of this substituent, and the way I'm going to get rid of it, I will use low concentration. So this one, it will be low concentration or diluted solution, while the first one was high concentration. So concentration of H2SO4 was high, and here the concentration is going to be low or diluted, and that group, it will be replaced by H, and here I will have BR. Okay, so now that's going to be my product. Okay, again, the way I got it, I block the para position. Now that I have only ortho position, any one of them, wherever we add the bromide, it will be in ortho position relative to the alkyl group. And next step, I will remove the blocking group by simply diluting the solution, and that's going to give me my product. I'm going to stop the lecture here, and thank you very much.